Hello everyone. Today I am going to explain some questions from miscellaneous exercise of chapter 7 from class 12. So we will start from the question number 3rd. Here we have to differentiate this given function with respect to x when x is belonging from between 0 to pi by 2. So here the given function is this. First I assume this given function as y, and to differentiate it, first we will try to simplify all these grouped. So inside it, what I had done is this one I replaced by the identity sin square theta plus cos square theta. But just see here what I had done. I used this property, that is sin square theta plus cos square theta equal to 1. It's an identity. Instead of theta, I took x upon 2. Why I had done, I will explain you. Because here we have sin x, and sin x, students, we can write as sin, this x we can write as 2 multiplied by x upon 2, and so that it will convert in the form of sin 2 theta. And what is the formula of sin 2 theta? 2 sin theta cos theta. Again I am repeating, first this 1 I replaced by the identity sin square theta plus cos square theta equal to 1. Instead of theta, I took x upon 2 because here the second term is sin x, and sin x we are going to split as sin 2 dot x upon 2, so that it will convert in the form of sin 2 theta, and we can use the formula 2 sin theta cos theta, where theta is going to be x upon 2. Now since sin x, when we are splitted, we obtaining here x upon 2, that's why here we should take x upon 2. So I hope it's clear to you. So these two terms came because of this 1, and sin x I changed by the formula 2 sin theta cos theta. In the same way here also and everywhere we will change by both the formulas. Now students, in next step, here when we observe it carefully, it is in the form of a square plus b square plus 2ab, and it is in the form of, so whole and whole it's going to be a plus b whole square, and it's going to be a minus b whole square, and it's going to be a plus b whole square, and it's going to be a minus b whole square. Now here in these two terms where we have negative, that is a minus b whole square, so it can be a minus b whole square as well as it can be b minus a whole square. Means you can write it as sin x upon 2 minus cos x upon 2 whole square, as well as you can write it as cos x upon 2 minus sin x upon 2 whole square. Now the question is, by what we should replace? So for that, students, we have to see our constraints. Constraints means where x belongs. X belongs in the first quadrant, and students, in first quadrant, when we see the graph of sine and cos, the cos graph have more height than the sine. So, and to bring this term positive, the cos is greater than sine in the first quadrant. That's why we will replace it by cos minus sine. So just see, I wrote here formula. When you have to write the formula 1 minus sine, root 1 minus sine x, you have two choice. You can write it as root cos x upon 2 minus sine x upon 2 whole square, or minus bracket cos x upon 2 minus sine x upon 2 whole square. Because students, here it depends on the x. If x belongs from 0 to between 0 to pi by 2, then you have to replace it by this, and if it belongs between pi by 2 and pi, then you have to replace by this. That's why here I replaced it by cos x upon 2 minus sin x upon 2. Now here I hope it's clear to you how we had done here. We had used the a plus b whole square. So where plus sign is there, it's not a problem. You can write any, like cos of x upon 2 plus sin x upon 2, as well as you can write sin x upon 2 plus cos x upon 2. But when you will write down for the minus, you should take care about these two conditions. It depends on the x in which quadrant it belongs. Now because of this square, it will come out from the root. So the square and root will cancel, and after all the cancellation we will remain with like this. Now here sin x upon 2 and sin x upon 2 will cancel each other, and here cos x upon 2 and cos x upon 2 will cancel each other. Remaining will get add. 2 and 2 will cancel, and cos upon sin is cot. What I wrote here is wrong, students. Sorry. Just write down only cot cot. Now this cot and cot inverse will cancel each other, so you will remain with only x upon 2. Now just differentiate it with respect to x, and very simply you will get the answer half. So it's this question is very important. So always take care that here the x belongs from where to where. According to that you have to select here. You are not going to select by your own choice that anything you just replace here. It's very important step that whether you are going to write cos x upon 2 minus sin x upon 2 or sin x upon 2 minus cos x upon 2. So take care of all these things and then do this question. Easily you will get it. Now we will do the fourth question. In fourth question we have the product of multiple functions. So when we have to differentiate the product of multiple functions, that time it's very simple. One function at a time you differentiate and other functions you just keep as it is. So here first I differentiated sine, and then here I differentiated e to the power x, and then here I differentiated x to the power q. So when I am differentiating one function, remaining functions I kept as it is. That's the process when we have to differentiate multiple functions when they are in product. Now here when we differentiate, sin x differentiation is cos x and ex differentiation is ex, and x to the power 3 differentiation by x to the power n and x n minus 1. So we will obtain this. That's your answer. So question number 4 is not so tough. Easily we obtained the answer by the formula that when the many functions are in multiply, that time at a time you just differentiate only one function, and we should take care that every function should be differentiated, and when we are differentiating one function, remaining functions will come as it is in multiply. I hope it's clear to you. Then also if you have any doubt in question number 3rd and 4th, you can write in comments so that I can clear it again. Thank you.